So for example problem 3.2, it states that a ballistic pendulum can be used to measure the speed of a projectile, such as a bullet. The ballistic pendulum shown in the figure, this one, part A, consists of a stationary 2.5 kilogram block of wood. So this is the block of wood, suspended by a wire of negligible mass. A 0.01 kilogram bullet is fired into the block. So this is the bullet. And the block with the bullet in it swings to a maximum height of 0.65 meters above the initial position. So this is part B. This is part B, and this height is equal to 0.65 meters. Find the speed with which the bullet is fired, assuming air resistance is negligible. So we have here the initial velocity, v sub O1 of the bullet, and it has a mass m1, or mass of the bullet. So this is the mass of the wood, and the height 0.65. So this will have a mass which is equal to the mass of the bullet plus the mass of the block of wood. So this will also have a common velocity v sub f. So in order to solve this problem, we will use two principles. First, this collision is classified as inelastic since nagsama na yung wood and bullet after collision. So we will, if the collision is inelastic, the total linear momentum is conserved. So by linear momentum, conservation of conservation of linear momentum. So we have 2.5 plus 0.01 kilogram. So, pinuna ko lang yung sa final times the final velocity v sub f. So, this is equal to the initial linear momentum, which is equal to 0.01 kilograms times the velocity of the bullet, which is equal to v sub O1 plus 0, since the block of wood is initially stationary. So, or it is not moving, so the initial velocity of the block of wood is equal to 0, and even if we multiply that with the mass to get the momentum, that is still equal to 0. So we have the first equation here. For the second equation, we will use the conservation of mechanical energy. So this involves the kinetic energy and the potential energy of the system. So for the kinetic energy, we know that it is equal to 1/2 times the mass times the square of the velocity. And the potential energy is equal to the mass times acceleration due to gravity and to the height h. So writing this one down, we have the first, let us consider the potential energy. So this, since the block of wood and the bullet is together, we can write that as 0.25 plus 0.01 kilograms times 9.81 meters per second squared times the height h, which is equal to 0.65 meters. This is now equal to the initial velocity. So initial kinetic energy. So we have 1/2 times, sorry, not initial, but just the kinetic energy, which is equal to 2.5 plus 0.01 kilograms times v sub f squared. So solving simultaneously, v sub f is equal to 3.5711. 3.5711 meters per second. And the initial velocity is equal to 896.3461 meters per second. So these are the answers.